for some of these problems, you will need to be able to find sine or be able to find cosine when you're given something different. So let's just suppose that you're told that cosine is 12 over 13 and it is in quadrant 2. And you need to be able to find sine. So what you need to do first is limit this to the quadrant that it's located in. And you know you have 4 quadrants. And you only have 4 reference angles. The reference triangles are drawn to the horizontal axis. So the 4 reference triangles look like a butterfly. They'll never be drawn over here to the vertical. They're always drawn down to the horizontal or up to the horizontal. So it looks like that. So if I tell you that it's in quadrant 2, we're talking about this reference triangle. And so we're looking at these angles, and I'm just going to call them theta. These 4 reference angles. Only 4. Never angles up here or here. Only these 4 in the middle. So if I tell you that cosine is 12 over 13, cosine is side adjacent over hypotenuse. If I'm talking about quadrant 2, I'm talking about this angle, and adjacent to that would be here, and hypotenuse would be here. Now what you have to be careful of is the sign. In the first quadrant, both numbers are positive. In the second quadrant, we're going out to the left and up. In the third quadrant, we're going out to the left and down. And in the fourth quadrant, we're going to the right and down. So when we look at these numbers, since the 12, and let me give us a highlighter so that we can see this a little bit better. Okay, so the 12 is that little section of that triangle, and it's going out to the left. Now what that means is that the 12 is actually negative instead of a positive 12 because it's going to the left. If the 12 had been in this quadrant, it would be this piece going to the right, and it would be a positive 12. So if you're looking at that piece on this side, it would be a negative 12. If we were talking about this piece, we'd be going up, so the sign on that would be a positive. Anytime you talk about the hypotenuse, though, the hypotenuse is this distance. It's this slanted distance. So the hypotenuse in all 4 triangles will always be positive. So you could have negatives and positives, or 2 positives, or whatever for the 2 legs of the triangle, but the hypotenuse will always be positive. So in this triangle that we're looking at, we have that negative 12 because it's that piece that's going from the center to the left. We also have this piece that we're going to need if we're going to be able to find sine. So we would need to use our Pythagorean theorem. So we have 13 squared equals negative 12 squared plus, and we don't know that other side there. Negative 12 squared is 144. 13 squared is 169. So when I bring this over, I get 25, which means that my missing side is a 5. And since it's the piece of the triangle that goes up, it is a positive. So you have to make sure that you get the correct signs on each piece of that triangle. Now, if I want to find the sine, S-I-N, of theta, side opposite is 5 and hypotenuse is 13. So that would be my sine for that one. If I needed tangent, Side opposite is 5, and adjacent is -12. And that's where this will come in. A lot of times we'll miss the tangent because we'll have the wrong sign on our piece of our triangle. So that's what we're looking at for these, and that's just a little bit of background for you guys.